All right, let's talk about a topic that I swear trips up so many people in technical interviews, the sliding window technique. And hey, if you've ever felt kind of lost with this one, trust me, you are definitely not alone.
I mean, let's be real, this is a huge stumbling block. A lot of folks get stuff like 2 pointers, but when it comes to why a window should slide or when it should grow or shrink, that's where things can fall apart. And what happens? You end up just memorizing code, not really getting the logic behind it.
Well, you know what? Today we are going to fix that for good. I promise by the end of this, you'll have a super clear picture of the two main types of sliding windows, and you'll know exactly how to use them. Okay, so let's get right into it. What's the core idea here? And maybe more importantly, why is this thing so darn efficient? Okay, think of it like this. It's all about looking at a specific chunk or a window of data, like a part of an array or a string. But here's the magic. Instead of doing all the math from scratch every single time you move over one spot, you just slide. You reuse the work you've already done. It's all about being smart, not working harder. And this right here, this shows you just how big of a deal that is. If you did it the brute force way, recalculating everything every time, you're looking at something called O(n) squared complexity. All you need to know is that's really, really slow, especially with a lot of data. But the sliding window, by reusing that work, it gets you down to O(n), which is just incredibly fast. We're talking about a night and day difference. It's a total game changer. All right, so there are basically two main flavors of this technique. We're going to start with the easier one to get our heads around, the fixed size sliding window. And yeah, the name kind of gives it away. The size of our window is always going to be the same. So here's a classic problem where this shines. Let's say you've got an array of numbers and someone asks you to find the chunk of, say, size 3 that adds up to the biggest number. That 3 is a fixed size, right? We know it ahead of time. That's a perfect signal that a fixed window is the way to go.
And the logic? It's actually super simple, which is why it's so cool. First, you just add up the numbers in your very first window. Then, to slide, all you do is add the new number that's coming in on the right and subtract the old one that's falling off on the left. That's it.
Okay, let's walk through this real quick. Let's say this is our array. Our first window is size 3, so that's going to be 2, 1, and 5. You add them up, boom, you get 8. That's our starting sum. Easy enough, right? Now watch this. We slide the window one spot to the right. Now, instead of adding 1 plus 5 plus 1 all over again, no way. We just take our old sum, 8, subtract the 2 that just fell out, and add the new 1 that just slid in. Our new sum is 7. See? So much faster. We didn't have to recalculate the whole thing. Let me just do it again. Slide to the right. We take our sum of 7, subtract the 1 that's leaving, add the new 3 that's entering, and our new sum is 9. Hey, that's our new maximum so far. And you just keep doing this simple add and subtract dance all the way to the end. So if you remember one thing about this, let it be this simple rule. Fixed window means you add 1, you remove 1, and the window size never changes. If you can lock that in, you've pretty much got this down. Okay, awesome. Now let's move on to the second type, which is a bit more dynamic, the variable window. And as you probably guessed, this is where the window can actually grow and shrink. This makes it, honestly, a lot more powerful for different kinds of problems. So, a perfect problem for this would be something like, find the longest part of a string that has all unique characters. See, with this one, we have no idea what the best window size is going to be. Is it 3, 5, 10? We don't know. The window has to figure it out as it goes. The logic here is kind of like an accordion. You keep expanding the window from the right, one character at a time, making it bigger. But the second you break your rule, like, oops, you just added a character you've already seen, you have to start shrinking the window from the left side until it's valid again.
Let me give you a quick example. Let's say our window is growing and we have A, B, C. Everything's great, all unique characters. But then we try to add another A. Now our window is ABCA, and bam, we've broken the rule. We have a duplicate A. So what do? We have to shrink from the left. We kick out that first A, and now our window is BCA. And hey, we're valid again.
And that is the core idea right there. You expand, expand, expand until you break the rule. Then you shrink, shrink, shrink until the rule is fixed. And the whole time you're doing this, you're just keeping an eye on the biggest valid window you've seen so far. That's your answer. Okay, now for what I think is the single biggest point of confusion for pretty much everyone. How is this different from the 2 pointers technique? Because I know they can look really similar, but they're actually used for totally different things. Let's just break it down. 2 pointers, that's usually for things like sorted arrays, where you're looking for pairs that meet some condition. The pointers can kind of move on their own. But sliding window, that is always about a continuous block, a subarray, a substring. The 2 pointers, the start and the end, they work together to define that one single window. All right, enough theory. Let's get practical. What are the common mistakes you absolutely have to avoid? And what are the key words in a problem that should make a little light bulb go off in your head that says, aha, sliding window? So here are the big ones, the classic mistakes. First, recalculating the sum every single time. I mean, that just defeats the whole purpose of being efficient. Second, for fixed windows, forgetting to subtract that element on the left. Your math will be wrong every time. And for variable windows, if you don't shrink when you're supposed to, your whole logic just falls apart. And on the flip side, here are the signals you need to look for. When you read a problem and you see words like subarray, substring, or continuous, that should be a huge hint. Same thing if they're asking for the longest or shortest or maximum or minimum of some continuous chunk of data. That is prime sliding window territory. So if you walk away with just one thought, let it be this. 2 pointers are for comparing elements, and those elements can be anywhere. Sliding window is for controlling a range, a connected block of stuff. Once that clicks, I promise you, a whole bunch of these interview problems will suddenly seem so much easier.